Assalamu alaikum students. Today we are going to study exercise 5.1 question number 4. In question number 4 we have been asked to find limit of a vector function. I read question number 4 for you. Evaluate the following. First part. Limit st approaches 0. Limit of square root t I plus sine t or t j plus cos t k. We are going to find the limit of this vector function. We already know that the limit of a vector function exists provided that limit of each individual component exists. We can write this limit with each individual component, but I have directly found the limit of each individual component. Limit of square root t st approaches 0. If we write in place of t 0, square root of 0 is 0. 0 times unit vector I. If we write a limit with these component sine t over t, limit of sine t over t as t approaches 0 is equal to 1. We already know it. Limit of, we have studied it in chapter number 2. Limit of sine x over x as x approaches 0 is 1. 1 times unit vector j. If we write a limit with the third component, limit cos t as t approaches 0, unit vector k. Cos 0 is equal to 1. 1 times unit vector k. 0 times unit vector I is 0, plus 1 times unit vector j is j, plus 1 times unit vector k is k. So the limit of this vector function is j plus k. The limit of this vector function is this vector, unit vector j plus unit vector k. St approaches 0. Now we come to the second part. Limit of this vector function. We have to find limit of this vector function st approaches 2. Again, we can write limit with each individual component. I have directly evaluated the limits of each individual component. Limit of 2t st approaches 2 is 4. If we write here in place of t2, 2 times 2 is 4. 4 unit vector, 4 times unit vector I. Minus 3j. It will come as it is, minus 3j, because there is no any t. Now we come to the third component. Limit of t squared as t approaches 2. If we put t equal to 2, 2 squared is 4. 4 times unit vector k. So limit of this vector function as t approaches 2 is this vector, 4 times I minus 3 times unit vector j plus 4 times unit vector k. It was the second part. Now we come to the third part. We have to find the limit of this vector function. T squared plus 1 divided by 3t squared minus 2 I plus 1 over tj plus 1 over t squared plus 2 k. We can write limit with each individual component. If we find the limit of the first individual component, if we directly put t equal infinity, then what will we get? We will check it. Infinity squared, if we put t equal to infinity, infinity squared is infinity, infinity plus 1 is infinity. We get infinity in the numerator. If we put t equal to infinity in the denominator, infinity squared is infinity, 3 times infinity is again infinity, infinity minus 2 is infinity. So we get infinity in the denominator. We will get infinity over infinity. It is an indeterminate form. So we will try another way or another method to find the limit of this individual component. If we take t squared common from the numerator, then we will get 1 plus 1 over t squared in the bracket. If we take t squared common in the denominator, then we get 3 minus 2 over t squared in the bracket. This t squared and this t squared get cancelled. So we get 1 plus 1 over t squared in the numerator and 3 minus 2 divided by t squared in the denominator. If we write limit with the second individual component, limit of 1 over t is t approaches infinity. 1 over infinity will become 0. So limit of the second individual component is 0. Now we will find the limit of the third individual component. Limit of 1 over t squared plus 2 as t approaches infinity. If we put t equal to infinity, if we put infinity in place of t, we get infinity squared is infinity, infinity plus 2 is again infinity, 1 over infinity is 0. So I have put infinity in place of t. We get infinity squared plus 2. Infinity squared is infinity, infinity plus 2 is again infinity, 1 over infinity is 0. We get 0 times unit vector k, 0j, it comes as it is. Now we will see the limit of this first individual component. If we put infinity in place of t, what will we get? 1 plus 1 over infinity squared. 1 over infinity squared is 1 over infinity, and 1 over infinity will be 0. So 1 plus 0 is 1. 3 minus 2 over infinity squared. Infinity squared is infinity, 2 over infinity is 0. So 3 minus 0 is 3. We get 1 over 3i plus 0j plus 0k. These two will be 0. So limit of this vector function is equal to 1 over 3 times unit vector I as t approaches infinity. Limit t approaches infinity. It was the third part. Now we come to the fourth part. Limit t approaches 1. There are two vector functions. We know that limit of cross product of two vector functions is the cross product of their limits. We will first find the limits of these two vector functions. Then we will find their cross product. We will first find the limit of this vector function. 2i will come as it is, minus 3tj. If we put t equal to 1, minus 3 multiplied by 1 will be minus 3j. E raised to power 1 will be e times unit vector k. Now we will find the limit of this vector function. If we put 1 in place of t, we get 1 squared is 1, 1 times unit vector I. There is no any component involving unit vector j, so we can write 0j. If we put t equal to 1 in the third component, cos pi 1, cos pi will be minus 1, minus 4 multiplied by minus 1 is plus 4. So we get 4 times unit vector k. The limit of this vector function is this vector I plus 0j plus 4k, and the limit of this vector function is this vector. Now we will find the cross product of these two vectors. We will make a determinant. We will write I, j, k in the first row. In the second row, we will write the components of the first vector. What are the components of the first vector? 2 minus 3e. 2 minus 3e. In the third row, we will write the components of the second vector. 104. 104. Now we will expand this determinant by first row. Write I here, neglect first column and first row and multiply these two minus, and then multiply these two. Minus 3 multiplied by 4 will be minus 12, minus 0 multiplied by e will be 0, and then minus j, neglect first row and second column, multiply 2 with 4 we get 8, minus, and multiply 1 with e we get e, plus k, neglect first row and third column, and then multiply 2 with 0, 2 multiplied by 0 is 0, minus, multiply 1 with minus 3. There is a minus sign here, minus multiplied by minus 3, or minus 1 multiplied by minus 3 will be plus 3. Minus 12 minus 0 will be minus 12 I. If you multiply this minus sign in the bracket with these numbers, the sign changes. 8 minus e will become e minus 8, unit vector j, plus 0 plus 3 will be 3 times unit vector k. It was the third part of question number 4.